A very good morning and a warm welcome to all of you to the second module of this exciting AI Pathshala on forecasting and optimization, brought to you by KTech, Center of Excellence Data Science and AI in association with Genpact. My name is Supriya Samuel and I'll be your host for the day. In today's workshop, we will understand the forecasting techniques like DES, TES and ARIMA. Our esteemed presenter, Mr. Rajeev Ranjan, will help you to understand the importance of optimization to connect the forecasting output with that of an actual business problem. Few housekeeping items for the day. Please feel free to queue in your questions in the Q&A window alone. For our subject matter expertise for the day, Mr. Sayantan Banerjee from Genpact to respond to. We value your feedback and will be sharing the survey link to provide your inputs on the workshop today. Also, we'll be sharing the link to the Excel file, which you can use for the hands-on session today. Without any further ado, I would now like to invite our esteemed presenter, Mr. Rajeev Ranjan, AVP Data Science at Genpact, to take the stage. Over to you, Rajeev.
Thank you, Supriya. Yeah, I welcome you back again. I know yesterday it was a almost 4 hour heavy understanding of what it is. And we may not have done our sessions yesterday, and we tried to close things with Excel. Today we will mostly work on our studios. And again, if required, we can go back to Excel and see something visually what is happening. But most of the time we will be on our studio and we will try to implement some of the modeling techniques for the forecasting engine. Okay. Before we start, as Supriya said, all the answers should be done on the Q&A. Please feel free to pose your question. We'll try to answer every question. Okay. And just like yesterday, after every, say, 50 minutes, we'll take 10 minutes break so that we can feel a little comfortable when after an hour when we start the session again, right? Same, I mean, everything is same. Only thing is today, the platform will not be Excel. Mostly it will be R Studio. So I am assuming that we all have R Studio open in front of us. And again, don't worry about the packages. We will understand what packages and how, I mean, where to download from and all those things. Only thing is our studio panel should be open, the editor. And Supriya would have posted the link to the data set that we will be using. The data set is exactly same as what we worked on yesterday. Only thing is, I did not have a Remax in my mind, explanatory variable in forecasting world. I had planned for univariate, but now yesterday I realized that maybe we should cover one of the model where we have one of the independent variable. So I have just added one independent variable there. Again, it's a real variable, and we'll try to see, I mean, how to use that, and we'll do it towards the end. First, we'll use the data as if it was yesterday without any independent variable. And when I say independent variable, the x variable, right? We will ignore the x for now. We will work on y, and when we move towards the end, we will try to use the power of that x also. Does it improve? Does it help? And so on. Okay. So I'll share my screen, Supriya. Okay.
Sure, Rajeev.
Do we all have access to this data set? I just want to make sure before we start the day. A very simple data set with 4 columns. It has weekday, it has date, it has alert volume, and it has an indicator called is holiday or not. Okay. This is the same data set what we discussed yesterday, if you remember. Nowadays, because of the Russia-Ukraine war, the sanctions are too much into effect from the payment platform companies business, right? And there are a number of payment platforms that are available to us, and we can utilize that to make the payment. So nowadays more alerts are getting generated when as far as sanctions are concerned, right? I mean, if unusual payment is done, that gets for review. So those alerts needs to be reviewed by manual intervention, manual efforts. So unless we understand how many alerts are going to be generated, we cannot plan for the resources that we need to take care of or to resolve those alerts, right? Maybe many alerts are genuine alerts, and many alerts are just because the algorithm that is already in place thinks that it's not a correct alert, right? That is why alert volume that you see is the same as the alert that is getting generated each day. Now, I had data from 1st of January 2018 to 30th of Jan 2022. So it means my data actually didn't have Ukraine-Russia say effect in the data, because 30th January is the last day that I have data for. So assume that that war has still not erupted, and we are fine with whatever alerts are getting generated on the regular basis. And we are supposed to forecast based on this history, everyday alerts, and try to see how many alerts are there, and what do we do after that alerts get generated. I mean, somebody has to plan for the resourcing, right? Now these alerts, it's my data is at daily level, but I know many of you may have come from this industry, call center industry, may have worked on the call center industry, contact center, say even the IT business where tickets get generated and so on. Although my data is daily, but there are businesses where hourly level data gets generated, and they need to plan resources at our level, not even at daily level. The more granular level you go to, the more difficult and less reliable and less accurate your model forecast will become. As I said yesterday also, forecasting for India is relatively easier than forecasting for every state separately. And forecasting for every city separately is even more difficult, right? So granularity always poses challenge. Okay, so I have my data at daily level. We will try to forecast at the daily level, right? And I know we have done single exponential smoothing and double exponential smoothing using Excel framework yesterday. We do not have to use Excel for the modeling purpose. My aim was just to show you that how the calculation happens and what is it that R does so quickly for us, or say Python does so quickly for us, right? So it is not that we have to learn that Excel by heart and we need to understand what it is. If we have missed it, it is fine. But if we have understood, it means we have understood the backend calculation, that how that parameters alpha and beta gets generated. Alpha in case of single exponential and alpha and beta in case of double exponential. Single exponential takes care of level, double exponential takes care of level and trend. As I said yesterday, in general, we go ahead with mindset that time series or forecasting series data, time-based data has 3-4 different components. First component is level. We should understand at what level we are standing at. Second, it's trend. We should understand whether there is an increasing trend or a decreasing trend, right? I mean, for example, if somebody would have studied the data around the regular TVs, right? The trend of regular TVs was coming down and trend of smart TVs was coming up, right? Again, I'm referring to the projects I did back in 2011, 2012, when I was supposed to study smart TVs and other TVs separately. And the trend for smart TVs were going up, and trend for regular TV was going down, right? Now, so we should understand what is the trend. So double exponential smoothing will help you address that trend problem. The issues with single exponential and double exponential was, as we discussed yesterday, that it is good for short-term forecast and it believes too much on recent data, and your trend and your level may not be good enough to go ahead with, right? And then there is another piece that we look at after level and trend. People look at seasonality. We have not done seasonality piece yesterday, that is called TES, triple exponential smoothing. Another name for double, triple are Holt's winter method also. We will try to do that in Excel and do that in RStudio and see how it performs. Once we have done the single, double and triple, we will move to ARIMA piece, which is a little different than these three, and then we will understand how different models are performing and how should we decide on which model to go ahead with, right? Now, let me know if we all have access to the data set that I have on my screen. Yes, Pranav says yes. So I'm assuming yes, most of the people are saying that they have access to this data set. Okay, thank you. Now, before even opening the say RStudio, if somebody asks us to look at the graph of this, even in Excel, the alert volume, this is the volume column C. This is the volume that we have from 1st January 2018 to 30th January 2022. So if I try to plot this, right? What happens? Say simple line graph. Very clumsy, and we don't understand what is happening. And it is just because too much data and very less space, right? But if you try to look at the data, say last 2 years. So I will start from the end and I will just try to, or maybe the complete 2021 data and whatever is there in 2022, less than even 2 years data. Let's see how the graph looked like, because when we plotted the graph at the total level, I mean, it was looking little clumsy. So we'll start from say 4th of January 2021 to end. Let us see this graph. Now it is not as dense as it was earlier. Again, it is just because we have less data points than what we had earlier. You will see in this graph that after every regular interval, there is a trough. Trough is opposite of peak. So this is trough, this is trough, this is trough, this is trough, this is trough. Every time it comes down. And when you study, you will realize that these all troughs are weekends. Right? It means the simple plot tells me that weekend you will have less volume. Otherwise, you will have on other days, they may not be equally distributed, but yes, you will have relatively higher volume or much higher volume, I will say. Right? This is the first impression we get when we try to draw the graph of daily graph of the data. Right? One of the piece that we have just come to know after reviewing this series. And this series is nothing but daily alert volume that gets generated for a finance company which offers the payment, which has the payment platform and people are using that payment platform. Okay. So something that we have just learned from the Excel. Now I will suggest that we all should now move to RStudio, try to import this data and see the plot there also. Maybe what we will do is we will try to make weekly, we'll club each week, and maybe instead of days we will see the even weekly plots and see what happens. And if do we get any information there, a different information. Again, chart graph will not give you any different information whether you do it in Excel or RStudio, but we'll try to plot this even in RStudio and see what it is. Okay, so everybody, let us open RStudio. I am assuming we all are on the same page, right? Now, some of the packages that we will be working with, which should be sufficient for whatever activities we are going to complete today. Okay. So I will suggest that we should have 1, 2, 3, 4, 5, 6, 7. 7 libraries or packages installed. First is forecast. We may not have any. If we have, please don't. If you do not have, let us install this forecast package in RStudio. And if there are some new people who are new to RStudio, the package installation is, look at my screen, right part, there is something called package. Click on this package. And then you will see a button called install. Click on install. And you can write the name of the package that I have written. Forecast. You can write forecast. It will come, the first one, and you will select this and click on the install. I am assuming we all understand the meaning of install. It is like once, it is one time. I mean, for your RStudio, it is like one time you have to install forecast. After that, you don't have to worry about it unless you need to update this forecast package or any other package, right? So I will suggest everyone to install forecast, Lubridate, ggplot2, dplyr, t-series, TS Studio, and knitr. Right? One by one, we can start. Everybody can see my screen. First is forecast. And do confirm me that if anyone is lagging behind, let me know that we have not installed, we are stuck. Do let me know. Okay. Okay, Ankita is saying install. Okay. Yeah, I mean, we will wait. Unless all these 7 packages are installed, we would not move ahead because our code will not run.
Team, please feel free to give a thumbs up once all of you are ready.
Okay. So many people have done forecast and lubricate. So we'll have. So there are 7 packages, and I don't think it takes any of these will take so much time, except the forecast.
Rajiv, Amruta is asking about TS Studio. Question.
She's not able to do that. Okay.
Are you not able to do that? She's just.
Okay. No. Okay. The first one, Amrita, it is the first one. Time Series Studio. You can read it like this. Time Series Studio. Last is KNITR package. Okay. Disha is done. Pranav is also done. Okay. Again, forecast, T series, TS Studio, all these things are related to time series. And GG plot is about the plots. Lubricate is about when you try to play around or manipulate the date function, create a month, and so on, right? Week. And DPLY is simple data operations. I mean, that anyway, whatever project you are working on, if you are working on RStudio, always keep DPLYR package on, because I mean, then only you can do data manipulations, data operations, right? KNITR, I'll tell you at the end. I mean, it has many other functionalities, but why I have kept it specifically is I'll tell you at the end, just to generate one particular table for review. Okay. So we have almost created the. Okay, so our library is installed. Now, once your library is installed, please write library command for each of these library, and run command is, I mean, you go to whatever line you want to run, just be in that line anywhere, doesn't matter you have to begin or the end, anywhere, you just have to press Control Enter. So it will run. So library forecast is the command, but to execute the command, you have to do Control Enter, right? So all this library command we have to execute, or you can select all this together and Control Enter. So everything will be run. So make sure that our library command is executed, so that I'm assuming we understand the difference between installing and and then running the library command. So you can remember or think installing as if you are hiring an employee in an organization. So hiring will be done once for a particular person, right? You have hired, for example, Rajeev once. So I am hired for my company Genpact. Now library command is just to make sure that Rajeev is available for the work. So every time the new project comes, you are giving a heads up to Rajeev. So it's like forecast you have to install once. Hiring will be done only once. Once you have closed your RStudio, you don't need to reinstall it. But once you have closed your RStudio, you reopen it. You again have to remind forecast that you should be ready. That's why to make forecast ready, you have to run the library forecast command, right? Library command is just to give an heads up that I may need your help. But installing is just that you have hired. So that hiring is one time, but keeping the resource ready is a number of times. Whenever a new project, you want that resource to be ready. So it's a heads up. That's how you can remember it, right? Difference between installing and library command. Once we have library command with us, we will try to read the data in RStudio. And which data? The data that Supriya has posted, right, in that folder. So bring that data in one of your folder in your, say, C drive, D drive, wherever you want. Bring it. You need to run the read.csv command, because the file that I have sent you is CSV file. So read.csv, and inside the single quote, you can give the path, and then you can mention the data name. Again, data name you don't have to change. Whatever I have is the same data name you should have. The only piece is if you are copying the path from the location, it would have backward slash. You have to convert all the backward slash to forward slash if you want to read the data in R, right? And if you still want to go ahead with backward slash, you have to use 2 backward slash instead of 1. So if you copy, there will be 1 backward slash. Either convert that backward slash to forward slash, or you make the number of backward slash twice everywhere. To make things easier, just convert everybody to forward slash so that you should be able to read the data. Let me know if we are able to read this data, or we all got error. For example, I am here, I will run control enter, and the console, like I can see that I didn't get any error. It means my data is read, and there is a file called data which is sitting in R environment now. So it has fetched the data from my local drive or my OneDrive, and it has brought in the R environment. Yes, people are able to read. I'm assuming I can read this as comment. She is able to read. I hope others are also able to read the file in RStudio. Shall we go ahead? Please feel free to tell me if we are lagging behind, okay? Okay, now next is, in that, although date command is there, but we are creating date from our side as well, just to make sure that everything is in created in R, so that R understands its language. And it is not that every time we have to, but just for the sake of unambiguity, I mean, we are creating a column called date, and this is the command that you can use for date. So in this data, I will create a variable called date. That's why data $date equals to as dot date, data $date, and the format is changing the format DMY, right? So 31st January 2021, right? Like that. So use this so that the format is DMY rather than whatever the format was earlier there. Okay. What did I do? No question. No. So are we all able to create this, run this syntax, run this command file? Now what happens is, many times, although your Excel doesn't have a problem, but for some reason R may read some of the numbers or some of the columns as non-numeric, right? It is not always the case, but just to make sure that R understands our data, that is alert, as numbers and nothing else. R has characters, factors, and all those things, right? So numbers. So I'm just trying to make sure that even if you don't run this command, there will be no problem, but just to make sure that alert volume is a number. So we are saying that data dollar alert volume equals as dot numeric, so that even if for some reason R has any intention of understanding it as character, it will convert it into numeric, so that number 10 is read as number and not character like class 10, right? So 10th class doesn't mean 10 is number, it's just a symbol, right? And it says that it's a greater than 9th class, only that. But 10th class doesn't mean twice of 5th class, right? It's just a character, it's just a number, is just a symbol, and the moment symbol comes, it will be understood as characters, factors. So I'm just trying to make sure that the alert volume is read as numbers and nothing else. That's why we have just done data alert volume is as dot numeric and data alert volume. Okay. Wednesday in the Excel file, and now that it's like date and then alert volume is holiday, right? Now although you can data dollar alert volume type equal to L. So instead of copying whatever I have written, you can just write data dollar alert volume. It gives you length, and you can see how zoom that, right? It is the same as what we saw in Excel. Remember, very dense graph because we had so many data points. 20 data from 2018 to beginning of 2022, right? 30th January 2022. So it's like 4-5 years data. So that's why you will have too many data points, and that is how the graph will look like. And again, you will see that every regular interval is telling you that data comes down to a very small level. And we know why. In Excel, we had opened and seen that it was because of the Saturday and Sunday that was coming. Weekend, the alert goes down significantly, right? Let me know if we can see this graph or not. Are we able to plot this graph? Again, may not be a necessary steps towards building an forecasting model, but yes, just to visualize, see how it will look like. Let me read. Yes, we can plot. So it means we can plot this graph and see how it looks like, right? Now this is the daily plot we just saw. Can we plot it, say, weekly and see how it looks like? If this is the daily data, let us see what happens when we club this, convert this data or aggregate this data to weekly level, just for our understanding purpose, how it looks like, right? So for that, you will have to create week information to that, so that it understands that, okay, this week, that next week, and so on. Because daily level is like 1500 points, so your week will come down, right, by 7 times. So it will have 200 and some points. So let us create a week variable, right? So let us run this command week, and maybe here also you can just use this. That's why if you look up, there is some packages like Lubridate and all those things, just to play around with this week information. Now if you run this, okay, now this is data for the week. Now we need to do the group by of this piece. Let me just bring the group by information. Okay, or we'll look at this week piece little later. We need to create group by. Let me just bring it, the group by information. Okay, so let us create and then we'll plot. So group by week, you will have to let me know if you all can see my screen. This piece, we all have to just try to, because our data is at daily level, we'll try to make it into a group. So how we'll make it to a group? We'll do some operations on the data. And what is that operation? So group by week is equals to data percentage greater than percentage means that you have to operate on this data. Command is group by year comma week. Then the command is percentage greater than percentage summarize. Now we have to summarize the sum of alert equals, you have to take the sum of for each of the week, and date is equals to first bracket date comma dot groups equal to drop. I'll give you time to read this and copy this. Again, this is not necessary towards building SES, DES, TES, ARIMA model. This is just for our EDA visualization purpose. Okay, so that do we understand how my data looks like at the week level? Okay, so if I run this, my group week data has got built in. right? Let me know if any of us are lost. Not a difficult command. Only thing is the percentage greater than percentage command is something that is connecting all the pieces. So data, then percentage greater than percentage, then group by. Group by which variable? Here week, because 1 week may appear in many years, right? So we cannot do it by week. Otherwise, it will sum the week of 1 of 2018 and sum of week of 1 by 2019 also. But we want to group it by every year week differently, right? And how do I want to do it? I need to summarize, and summarize means sum and not mean. So summarize, sum alert equals, sum alert is the name that we are giving. We can give any name, and sum alert volume. And data will start from where? Date is first date. It means first date of that week. We'll consider the week. We'll give a name to that week, right? Week of say 1st January, week of 8th January, week of 15th January, right? And then at the end, comma, dot, groups equal to drop. I don't want to know the names of that. So we'll drop it. Just see that we all have been able to run this command group by week, and we'll see how the plot looks like. Can I assume that we all have run it? Again, you can just in the chat, you can just give me a thumbs up information or yes, no, something, so that I know that Varun has got an error. Anyone else has got an error? We should not have got an error if we have all the libraries in place. And try again so that there is no drop. There is a dot before groups at the end. Dot groups equals in the single quote drop, right? And if you plot this, this is my data set that I just created group by week. In this, I can create some alert, and I will just plot it. Type equals L. The right side plot should get generated. Would you share any links if shared earlier? No links I have shared. We are just the link was only for data, and Supriya has posted this somewhere up. Yes, okay. R is case sensitive. In case we missed it, R is case sensitive. So if for some reason your variable name is capital N and small AME, and in the R you are writing small NAME, it will not work. R is case sensitive, and we have to be careful around it, right? So it will run, and when you plot, you just plot this name the data set and what is the variable inside it, sum of alert, and type equal to L just means it should be a line graph rather than something else. So if you run this command, you should get the plot that I'm getting at the right piece, and you can zoom it and see the plot. Do we see anything in this plot? Do we see anything in this plot? Do we observe something? When we look at the weekly plot, do we find something? Any story that comes out by looking at this data? Anyone? Correct. Everybody is saying there is a trend. So you will see that if you divide this graph in 3 batches, you will see that those 3 are, second is more than one, third is more than second, and so on. So it means it has an increasing trend. So it means whatever model you build, trend is very important in this case. Whatever model we build, we should make sure that trend is taken care of, because this data seems to be having trend, right? So weekly data, the moment we plot it, we see that it has a trend piece sitting in place, right? And the daily data, when we saw that it has a, I will say, seasonality piece sitting in every weekend. Every weekend numbers were low, right? So these are the two informations we could just see when we plotted the data at daily level and at the week level, right? Once we do that, then our task becomes that, okay, I should be running models which have seasonality inside it, which should take care of trend and so on. We will finish even SES through this, and we did it yesterday. And SES will not work just because we see that the data is having trend, and SES doesn't capture trend. SES just captures level. And when I say SES, it is single exponential smoothing. Single exponential smoothing only takes care of the level piece. It doesn't talk about trend. So once you have given one number, it will continue to believe on that same number as an output, and even whether you forecast for 10 days or 10 months, it will say that this is my output, right? So flat forecast and same forecast, right? So SES will not work, but again, we will still see and understand what is it that SES is giving us. Similarly, we can try DES. We will think that DES will work, but I'll show you when and how it may not work. Now, looking at this data, it seems that this data seems to be having seasonality hiding on each weekend, right? Seasonality hiding on each weekend. So what I did is I converted this actual data, that daily data, into time series data. Again, we have to anyway convert data into time series data, because R needs to understand that it has to perform time series processes and so on. For that, it has to consume time series data and not regular data frame data, the regular data frame that we have, right? 3-4 types of data structures that we have by, which is everybody knows in R, right? Or in Python, everybody knows vector. Vector is like any column. That column can be numeric, that column can be character. Then there is something called matrix. Now matrix has a problem that every column, every row should only have numbers, numeric. So matrix has a problem that it only understands numbers. In matrix, you cannot write A, B, and C. You cannot write any character. So matrix has that problem. But the data that we get for our consumption, for our use, whenever client shares data or whenever we pick up any data for our analysis, it will never come in a matrix, because every time you will see that there is some indicator, there is some name written, there is some, so for example, name of students and then marks, for example, product's name and its sales and so on, right? It means we cannot do things only with metrics, so we move to data frame. Data frame is like just like in structure, it is metrics. Only thing is it allows you to have some columns as characters, some columns as numerics. But again, in data frame also, you cannot say that one column, one row will be numeric and another row will be character. No, this freedom is only with respect to columns, not with respect to rows, right? So columns, you can have first column as product name, and you can have second column as sales. So second column is numeric and first column is product name. So data frame, that's why data frame is more useful to us. Now after data frame, people go to list, and list, I mean, you can have now any structure, because data frame and matrix, they have tabular structure. So list may have any structure. Now R understands all these four, but there are different scenarios like time series. It understands time series in a different way. So we have to make sure that we convert data into time series so that R understands it, that it is time series. Okay. So here what we will do is we will convert our actual data into time series. Okay. And when you convert into time series, it will ask for the, okay, what is your frequency of data? It means when do you think your one cycle gets completed? So cycle gets completed, I mean, you can say that my cycle gets completed each year, my cycle gets completed maybe each month, my cycle gets completed each week, you don't know. And you can keep on trying many things. In our case, I have, when I was building this model, I have taken frequency as 7, because I could see in the seasonality piece that every 7 days there is a trough coming up. So I just did the frequency as 7. So everyone convert this data, the data that we already had, convert this into time series with this command. Let me know if it is not clear to us. Just right. One of the statement was level goes up everywhere. Yes. And who will take the level up? That is the trend that will take the level up. Okay. Everyone, do you think we are able to convert our existing data into time series data? The syntax is very easy. Again, left hand side, I have given some name. You can choose to give some other name, but just follow the name that I have taken, so that whenever we refer this data set, we all are on the same page. So data TS1 equals TS. TS is the command for time series, converting the data into time series. And actual data is data dollar alert volume. Start is equals to decimal underscore date as dot date, this date, close this, and then frequency equals 7. You can experiment with other frequencies also. That's like after this workshop, no, you can try many things and see which is working better for you. Okay, this frequency is 7. Let me know if we are able to convert. This command is corrupting my data, data as dot data, data format. Here is changing to 20. No. Then there is start again, because hold on. I got one statement, this data is corrupted. So if when I plot this, no, it should not get corrupted, because I can see in my screen that data is 2018, 2019, 2020. If you follow the code from the beginning, it should not corrupt your data. The year should be from 2018 to 2022. Maybe retry. Line 18. That's why after running line 18 only, I have run the line 23. And line 23 gives me the x-axis, the date that I have, right? So I have used the output of 18 only. Why should it should be in double inverted comma? Okay. Okay, maybe Sayantan will parallelly help you to resolve the issues. Sayantan, see that parallelly if you can resolve the error that somebody is getting.
Yes, sir.
Okay, no problem. Thank you. Okay. So whoever was able to convert this into time series? Anyone was able to convert this data into time series? Okay, Manish says yes. Dhyasni says yes. Okay. Disha says yes. Okay, so there are people who are able to convert this into time series data. So we have converted into time series data. This data is now time series based. Earlier it was like data frame. The data that we read, it was read as a data frame. Now data TS1, it has become a time series data, right? So time series data. Okay. So Supriya, maybe we'll take 8 to 10 minutes break because we just decided that in the beginning we decided that every 50 minutes we'll take one small break so that people can get a little relaxed and then we'll move ahead.
So do we come back by 11:50? It's 10:56 now, 11:10.
Yes, maybe even before that, if possible, 10 minutes. I was thinking 11:06 to 11:10 we should be here.
Sure.
Okay. Thank you. Should we start?
Yes, Rajiv.
Okay. Okay, let's. Oh my God, why did I open this? Okay. So we have reached till this step that we have converted our data into time series data. Now, we need to convert our data, or I should say, split our data into two pieces now. It is just like when you have, say, 10 years question paper of any exam, past 10 years paper, 6 years paper you see, and you do your study, and then you appear for as if you are given exam for rest of the 4 paper and see the rest of the 4 years and see that how good you are, right? So one is called training, another is called testing, right? So for that, we can run this command. This command will split the data that we have, okay? And at the end, you will see that sample.out equal to 91. It is just saying that last 91 records, keep it for test. Otherwise, everybody keep it for training, that is model building activities, right? So this is what this command is doing in RStudio. Let me know if you are able to run this. This command is just for breaking purpose, right? Train and test. So first is train, second is test. So it means we have 5 years, almost 5 years data, right? Now in that 5 years data, we are saying that last 91 days data, keep it for testing purpose. Prior to that, please run it for training building. Other in other sense, we have said that we will train our model on the data starting 1st January 2018 to 31st October 2021, and then November, December, January data is left for testing purpose. November 2021, December 2021, and January 2022. That is ending on 30th of Jan. Right? This is what this command is doing. You can always play around with this 91 number. You can say that no, I want to keep 6 months data as testing. So you will make it, say, instead of 91, you can make it 180 and so on. But idea is that we should always keep more for training and less for testing. Just the way, I mean, we study full year, but we appear for test just one day. So it means testing period is less and training period is more, right? That's why, I mean, we never do that 50% test and 50% train. No, never happens. It's always big proportion is for training time and less proportion is for testing time, right? So that's why 91 I have just kept, but you can always play around with this number and see what you want to look at. Everyone fine with this statement written in line number 57? TS split is the dataset name we are saying, and then the command is TS split itself. And in the bracket, you have to write TS time series object. And what is the time series object? The one we just created in line number 53, data TS1. And comma, then it needs to know what is my breakup point, from where I should break into train and test. So it means sample.out. It means this should be out from your training purpose. So 91. So 91 we are removing, correct? No doubt. Okay. Anthony is taking care of that. So splitting the time series into train and test. Once we have done that, we will give a name to our time series data, which is training data, and one which is called test data. So train TS will be our time series data, and this is nothing but TS split $train. TS split is created in line number 57. So TS split $train and TS split $test. So now I will have two data set, train TS and test TS. Train TS is TS split $train and test TS is TS split $test. We all should be able to run this command, right? Let us see that we don't have any problem till line number 60. Can I assume that we all have done till line number 60? Now we have control of train TS and test TS. Yes, I am getting response, so it means we are good. Now we have done the breakup of data into train and test. It means we will build our model on training data, and then we will check our performance on test data. That's the data into train and test. The teacher will teach you questions, but some questions teacher will keep with herself or himself that can be asked in test, and then you will be actually checked how good your learning curve was. So now performance comes. So it means performance for test, and we should know. So what happens is we should then understand what do we mean by performance, right? Yesterday when we were doing our exercise on Excel, one of the performance metrics we had taken was RMSE. That's why in the solver, if you remember, we were trying to minimize RMSE, root mean square error. We were trying to minimize it, so that we will say that my root mean square error, which means my error is minimized. So whichever has minimum error is the best performer, right? That's what we were trying yesterday. So it means there are different types of metrics that you can use as a performance metrics. Let us go to this slide that I was discussing yesterday, and let me know if you all can see my screen. So these are various error metrics, you can say, which people generally use. Mean deviation, mean absolute deviation, mean squared error, root mean squared error, mean percentage error, root mean squared error. Again, root mean square error is, I mean, it is like weighted one. So there are many metrics that people go ahead with. I will choose one of the metric for our studio purpose, that okay, which metric we should go ahead with, and I will tell you what is that metric. This metric I am calling it as WAPE, weighted absolute percentage error. Weighted absolute percentage error. And I will write a function. That function will consume two arguments, x and y, and based on x and y, it will give you output, and that output is like WAPE. So how it is written in R? In R, function is always you have to give name to a function. So my name is WAPE, weighted absolute percentage error, and this equals to function. Function is a command in R, so you will write function. Now, after function, you have to write things in bracket, and bracket needs how many arguments. For example, addition is also a function. Addition needs how many arguments? 2. For example, addition needs number 2 and number 3, and output will be 5. Similarly, multiplication also need 2 number minimum. I'm saying, right? You can always write 3 numbers and you can add 3, multiply 3. Here I am saying my function needs 2 inputs. One is y column, another is y prediction column. So if y is like actual y, something that was actually given to me, actually the answer was, and y prediction is the answer that I gave, right? Now, how based on this, the actual answer and the answer that I gave gives me WAPE. So it says that your output will be, you convert y and y predicted both as numeric. If there is any ambiguity, then for that statement I always intend to write as dot numeric so that there is no confusion for R. And the output will be sum of absolute of x1 minus x2 divided by sum of y into 100. Okay. Again, this y can be written as x1, doesn't matter. As I said, x1 in line number 67 is nothing but s dot numeric y. Actually, I should have written x1. Okay. So this is the function of WAPE. And once it starts with a curly bracket, you should close this with a curly bracket. And function, loop, everything you cannot run line by line in R. Whenever you are writing any if loop, for loop, functions, you have to select the entire piece, because R doesn't understand if you don't give the closure, because it understands the opening, but it will not understand where to close. The close it will see, it means it will understand that, okay, there is a loop, there is a function, and I need to start and stop somewhere. So you can write this and control, enter. It will not give you any output because it is just a function we are creating. And the function, for example, is, I mean, addition function is already there in our calculator, right? Plus sign. It's like function. You write 2 plus 3, answer is 5. But your calculator may not have, say, sum of squares function, right? That if I give 2 and 3, the answer will be 13. That is not there in calculator. We'll have to do that. But you can always create that calculator in your RStudio, in your Python programming, wherever you want. So this is the function I have created for WAPE. WAPE is nothing but I will check the actual answer and my answer. It means actual for number and the forecasted number. Compare the difference and remove the signs of the difference. If the difference is -3, treat it as 3. If difference is +3, then also treat it as 3. That's why absolute. So percentage error and removing sign means absolute. Once I have done that, I will take the average of that percentage error. But that average will not be the regular average. That average I will take it with the weight that is there in the actual number. And when I say weight, it means if somebody is trying to forecast 1 as 2, the difference is very less. It's just 1 unit. But in terms of percentage, the number is very huge. If you are predicting as 2, it means you are doing 100% error, right? 2 is 100% more than 1. But at the same time, if you are predicting 200 as 210, your percentage error is just 5%. But absolute wise, you are doing 10 units error, right? So weighted means I am giving weights according to the actual number it has. If my percentage error is even more and the actual number is like 1, 2, and 3, it should be given less weight, right? If my percentage error is more and the actual number is also more, if I'm doing percentage error of 20% and the volume is like 1 million, then actually the error is too high, right? So to make sure that percentage error is in line with the actual volume that I have in the data, I am using this metric called WAPE. Okay. Feel free to post questions on Q&A. Okay. So WAPE. So can I assume that we all have run this command WAPE, selecting everything together and then doing control enter? Yes. What is same? SMAP. No, I mean, I don't think maybe that is something else. I may not understand SMAP. MAP is mean absolute percentage error. WAPE is weighted absolute percentage error. Maybe somebody would be using SMAP, using some other calculation. Once I have this WAPE, it means I know my train and test. I know what performance metric to use. I will now run different types of models and check my performance on that metric. Okay, so we will start with say SES. Okay, SES is that we built in Excel also yesterday. SES is single exponential smoothing. So very simple syntax. Since yesterday I had told you that three most important component of time series: level, trend, seasonality. It means there are three parameters we should always be thinking about, three P's that we should always be thinking about. Whenever we are trying to use exponential smoothing, it will try to address these three if you are using the full-fledged exponential series, and that is called the end, that is triple exponential series. But when you are at single exponential series, it means you are saying that my trend is off, my seasonality is off. That's why the three parameter that we call in exponential smoothing is alpha, beta, gamma. So the moment I am running SES, it means I am saying that beta is off and gamma is off. That's why you will see the command Holzwinter trend TS, beta is F and gamma is F. It means don't worry about trend, don't worry about seasonality. And you will, and it's very easy command. As I said, exponential smoothing are also called as Holzwinter method. So Holzwinter's command you will give trend TS anyway is the data that you should be training with. Beta is F, gamma is F. You will get this SES. Right? And if runs SES, you can print. You can print this SES. Run the right SES and run it. Oh, I should have first run it. No, why? Okay, I have not run train TS. I just kept on saying everything. Okay, map also I think map I have already run. So now I'll go and run SES. So my SES is run. And this is the SES piece. Everybody, are we able to run SES in our studio? Okay. Beta, gamma anyway will be off because we have said that it is off because we are running SES. Then it will give you just one parameter called alpha, 0.031, right? And don't worry about coefficient. Coefficient is nothing but 4978. That is the next forecast number that it will be. And as I said, SES always gives you level and it will be a plain forecast. So even if you forecast for 10 days, this number will remain same. How do I know this? Run the 76, line number 76, ses.pred. Again, you can give any name. I have just given that ses.pred just to say that it is prediction because of SES. So predict SES 91. It means I want to predict for 91 future, because you remember in test data we have kept 91 as tests. So I can predict SES 91, and I can print this. The number gets printed because it only gives you level. So flat forecast, right? Flat forecast. Now, if you run, I'm assuming we all are on the same page and we are able to run. Okay, great. Now, assume that you want to plot and see how my train TS looks like, how my test TS looks like, and how the fitted means. If you look at line number 81, fitted means whatever the forecast it gives you for the training data, and pred is what we are getting for the testing data. So if you run all this command, okay, you don't worry about this, even you can ignore this. For the class, I have run little so that we all can. If you run this, you will get the screen like this. Black is your actual data, test plus train. Blue is the training forecast that it has done, and the red is the testing forecast. You will see that the red is very small because we have just 91 days, but it is a flat line. Let me know if we are able to plot this. Plot train TS lines. Again, test TS, we are giving the black color. Fitted, we are giving blue color, and the future forecast, we are giving red color. Right? Make sense? Are we all good till now? Are we able to run and see the graph? I hope we are not lost. We are looks like data also, and in testing data also. Training data is like how much error you have done if you are asked the same question which you were taught in the class, and test data is how much error you have done if you have asked, if you are asked a new question, right, which was not taught in the class, but you should be able to answer that. So training is like that. So error in training. So SES web train. Web is the function that we have already created, right? And it needs two argument. What is that argument? Train TS, and another will be SES fitted, comma 1. Fitted means the output that we have given in the training data. Run this, and don't worry about the warning. Okay. Similarly, you can calculate the WAP in test data. Are we all able to do this? Are we able to do it? Okay. Fitted values. Okay. Don't worry about time in 2050 and all those things. The time is 2050 because the question is why time is 2050. Don't worry on that. The reason is, remember, I mean, we said that our frequency is 7 days. So what R has understood is that 2018 is 7 days, next 7 days is 2019, next 7 days is 2020, and so on. So don't read the x-axis, see the forecast, because we'll be using number and we can always arrange date as per our convenience. Fitted values. Fitted values is nothing but the value of your forecast in training period. Forecast is always supposed to be for the future. But I am saying that, okay, you may have trained on some data, but for the same training, what is your forecast? You must have used logic for which you are using the data, right? So training, in terms of exam, as I said, the answer to the question which were taught in the class is fitted. Answer to the questions that are not in the class but it is for the test is the prediction, forecast, right? Are we all able to run this web of train and web of test? Don't worry about the third line, it is fine. I have a habit of combining train and test, mean of train and test, but you can choose to ignore it. So web of train and web of test. If I print the web of train and web of test, the percentage error in train is 47.81% and percentage error in test is 53.7%. It was a huge percentage error, almost 50% percentage error. Error is giving, and which is understandable. Why? SES was supposed to give only level, just one number. And how can we expect that one number to be closer to all the answers? You cannot give the same answer to all questions and expect that we will pass the exam, right? So it's not the correct way. Agree or we are lost? Okay. Okay, great. Some responses I'm getting. Okay. Now what we will do is we will run the same SES, copy the same SES command. Copy the same SES command that we had run. Okay, this piece. Replace SES name with DES. Okay, and inside that now I just don't need seasonality. I need level and trend, double exponential smoothing. Now I am saying that, okay, I will use level and trend both. So I will use gamma equal to F and same code will continue, right? Don't worry about plotting. Plotting again, you can always check. So you need not plot things. Just run these two commands so that we can have DES model run and the prediction done. So if I run this and if I print this, now I will have two P's. Alpha is 0.12 and beta is 0.21. Gamma is false because my seasonality is still off. Again, the coefficients, don't worry about it. Coefficients is A is for level and B is for trend. A is for level and B is for trend. For some reason, it has picked up the wrong, the decreasing trend, which is not correct. And the reason is we started with 7 days frequency, and because of that, the last data that it sees the weekend data. Remember, last 91 data we have left for test, and remaining everything is for train. In the train, the last data is for Saturday and Sunday, and in Saturday and Sunday, numbers are decreasing. That decreasing trend it has got. It means actually it will not work for us. See, we can predict, and we can again calculate line number 103, 104, 105. You can just copy your previous web train and web test. You just need to replace SES with TES, and your web of train and web of test of DES, everything will come. So if I print these two, see what happens. My training WAPE is 43%, but my testing WAPE is much, much higher, 85%. So it will not work. So even DES is not a good model to go ahead with this data. Not hearing, not getting any response. Are we good with this run of DES and why it will not work?
Participants, please give us a thumbs up if you're all good.
Yes. Okay. Okay. Thanks. Thanks, Manish. Thanks, Anand. Vandar, thank you. Yeah. Okay. So it means we understand DES. So now I will do the same operations for TES, that is triple exponential smoothing. Now triple exponential smoothing takes care of level, trend, seasonality, everything. So it means I need to have everything on, alpha, beta, gamma, nothing will be false. So I will not write anything in the bracket that gamma equal to false, all those things, nothing, so that everything gets printed. And I will run this TES. Okay. And I will predict also using TES. Don't worry about the plotting. Just create the plotting, you can see later on. Just create the or you can do plotting. Only thing is SES, DS, you have to just replace with TS. Okay, of these two. In the wave function again, you don't have to, you just need to copy the previous one. You just have to replace SES with TES or DES with TES, right? Everywhere. And your wave will come. Okay, the question. Okay, so we expect the test wave to be around trend wave. Not only that, we expect both train and test wave to be very minimal. Zero means there is no error. I am perfect in my forecasting, in my prediction. 85% error is very high. I mean, very bad error. I mean, it's like I was asked to predict 100, I am predicting 185. So percentage error should be very less, and at the same time, for robustness purpose, test and train wave should be very similar or closer. It will never be same, but we should attempt to get them similar, right? Now, if you do this test, TS web, TES, and all those things, right? I will do for train, test, everything. Okay, we have done that. And I will print. Look at the error we are getting in case of train and in case of test when we have TES model. It is like 12.68% in train and 18.9% in test. So 19% and 13%. They are not same, but they are still closer and both are lower. It means TES is a much better model than SES. We know why. Because this model has trend as well as seasonality sitting inside it. Right? It has trend as well as seasonality sitting inside. That is why we take care of this data. So nothing surprising. So I just showed you the always right. If you zoom it, just plot at the TS piece, you can always see the red is the forecast, black is the actual, and blue is your training forecast. Red is your forecast of test period, and blue is your forecast for the training period, training data. this is how it looks like. I'm assuming that we understand SES, how to run SES, DES, and TES, and most of the time we should attempt for TES because it will try to explain for seasonality and trend both, and SES will only explain for level, and SES and DES will try to explain for level and trend. And this is the case where you will see that even with level and trend, it is failing because it is catching the wrong trend, right? So if we have trend and seasonality, it always only again TES amongst the exponential smoothing. TES works best when you have seasonality in your data, trend in your data. Everything is there in your data, then TES will work better. And yes, most of the time doesn't work better just because it gives you flat forecast and you may not be interested in that. SES is good only when you know that I have to forecast for tomorrow. I just have to forecast one number and I have the history. I'll just take a guess on tomorrow's number, very short term, right? TES takes care of trend and seasonality both, right? And SES and DS are not accurate because short term and 91 days we are checking, and SES gives you just one number. How can that one number be same for 91 days? So it means there has to be error. Okay. Now go a break. Let's spend 10 minutes on. I'm assuming no question now. Which library is helping in this smoothing? As I said, whenever you are doing any forecasting, be sure that you're forecasting time series things on in your studio. Forecasting package library you should take care of most of the things. Okay. So can we move ahead to the next? Now exponential smoothing I'm done. So can we move ahead? Great. We will move ahead. Now we will try to introduce ourselves to a world of different modeling technique, which is called ARIMA. Okay, ARIMA. Whenever it comes, just break it into 3 pieces and understand what it is. First is called AR, second is called I, and third is called MA. So AR, I, MA, that becomes ARIMA. Okay, and it has 3 parameters PDQ, as you see. PDQ. P is for AR, D is for I, and MA is for Q. I'll tell you what all this PDQ actually means. But for remembering purpose, AR, I, MA. This is AR, this is I, this is MA. Now, what do we mean by AR? What do we mean by AR? I think for some reason, equation has gone. Okay. AR. Whenever you are trying to forecast for a time period T, and you are using previous data, A1 times YT minus 1, A2 times YT minus 2, and so on, plus some error term, then this equation says that I am only considering AR. It means auto regressive. It means I am getting regressed on myself. It means only thing is time is changing. Today is dependent on yesterday T minus 1, day before yesterday T minus 2, and even one day before, and so on. Everybody will have different parameter. It has A1, it has A2, it will be A3, and we need to find that A1, A2, A3. We don't know what is the A1, A2, A3. This is like AR term, right? This is called AR term. Now we'll talk about I little later. Now understand this MA term, AR and MA. Let us understand this MA term, moving average. If you have only MA term, it means today will be dependent on yesterday's error. Any yesterday you also want done some forecasting? There has to be some error related to it, right? So that error plus error of day before yesterday plus error of day before even one day. The difference is auto regress. I will get regress on myself. Y is regressed on Y itself. Only thing is time is changing. Today is not yesterday. In MAPs, today's Y is explained by yesterday's error and day before yesterday's error. Yesterday's error and day before yesterday's error. This is MA component. So ARMA. So I'm assuming that we understand in ARIMA world what is AR and we understand in ARIMA world what is MA. So AR and MA. Okay. So if it is only AR, it means P00 model. ARIMA will be called as P00. If it is only MA model, it will be called as 00Q model. I don't know what is Q. Q is how many I should take care. Should I go to T-1, T-2, T-3? What is the maximum lag I should stop? That is like Q. Similarly, P, what is the maximum auto regressor I should be looking at? If P is 2, then it means I will stop at YT-2. I will not go a day before. Right? So P, D, Q. P is for auto regression. D is called moving average. I have not yet explained D. Let me take. It will. The only thing is in exponential, you only depend on today is dependent on in exponential. If you exponential was today was dependent on yesterday. Yesterday was dependent on day before yesterday. Now I am saying today is dependent on yesterday as well as day before yesterday, but with a different weight. Today is dependent on 60% yesterday, 30% yesterday, 10% even a day prior, and so on. This equation is little different than the exponential smoothing. But yeah, okay. Now, who remembers yesterday's question? I mean, anyone? I know I got many responses. Yesterday's question on what is the next number? Have 1, 2, 4, 7, 11. What is the next number? Many people have given me correct. How the weight is, we'll come to know how the weight is decided in AR. We'll come to know. The weight is again, we will have to minimize our error and we'll see that which A1 and A2 in case of AR will minimize my RMSE. For example, in Excel, we were doing that, right? This AR can be done in Excel also. We will just write equation A1, A2. I don't know. I will ask solver to give me, or I will ask RStudio to help me, right? Anyone remembers yesterday's question? The series was 1, 2, 4, 7. Yes, correct. Anand remembers correctly. So what is our response to the next number? What do you think our next number will be? Okay, everybody is saying 16, which is the correct answer. Which is the correct answer? That 16 is the correct answer. And why? And we all had done this in our school days, right? For example, if I write 1, 2, 4, 7, 11, and I need to fill up this number. A very simple piece is I will do this minus the previous number and I will try to drag this. And I see that the pattern is 1, 2, 3, 4. So obviously I will think that this pattern is 5. It means I need to add 5 to 11. So it becomes 16. Looking at this number, things doesn't seem to be very straightforward. But the moment you took the difference of 1 with the previous, this becomes 1, 2, 3, 4, 5. Even to make life even simpler, you can take one more difference of the second one, this minus this. And now you will see that everywhere answer is 1. And if you have series like 1, 1, 1, 1, 1, 1, 1, it's very easy to predict. It will be 1, 1, 1 only. And based on this will keep on changing. Based on this will keep on changing, and your forecast will be generated, right? This is very easy to forecast. I mean, if somebody has to forecast what will be the number of days in January in 2050, you don't have to worry. You just know 31, because every time you have seen 31, so it will be 31. So it's like 1, 1, 1 constant. But this made our life easy. But how did we get it? We got it by differencing. We got it by differencing, right? It means, think about the property of this series versus property of this. This series, as I move ahead, the numbers are increasing. Can I make a statement that as I move ahead, I consider first 3 records, and then I consider next 3 records, then I consider next 3 records, and next 3 records. Every consecutive 3 records, average is increasing. Can I say? Sorry. Anybody? Okay. Okay. So average is increasing. It means if this is my date, 1, 2, 3, 4, 5, 6, say date of this month, 1st March, 2nd March, 3rd March. So with respect to time, the mean is changing. Whenever with respect to time, the data property in terms of mean and variance. By the way, variance and standard deviation are related, so I'm not taking the name of standard deviation. Otherwise, you can say mean and standard deviation, right? Mean and standard deviation, if any of these changes doesn't remain similar, the series is called non-stationary series. Series is called non-stationary series. Whenever series is stationary, you will see that, for example, last one, wherever you are, the property is not changing, right? It is not changing. So in ARIMA, one of the requirement is that your series should be stationary. You should make your series stationary. And we know why. Just by intuition, but just by recalling our school days, we know that life becomes very easy in prediction when things are stationary at hand. Because I mean, it's very easy to forecast. The moment things are, again, that I know where I took it from. It is like column B, I gave you this. This is called as that APGP series when we were in school, right? So you have to take difference and then see whether it follows AP series or not, and so on. Arithmetic progression, geometric progression, and so on. So life becomes easier if we have stationary series at hand in terms of prediction. So in ARIMA, the requirement is that your data should be stationary. That's why I had asked yesterday that what it is. If your data is not stationary, how did I make it stationary? I took the difference of the consecutive term and I again checked. Again, it is not, I will check, I will do one more differencing. The number of differencing you have taken or done to make the series stationary, make the series stationary is called as I component of ARIMA. I is for integration. Okay, So in ARIMA, P is auto regressive component. D is how many differencing you have taken to make it stationary. Q is how many moving average we are, how many lakhs for the moving average piece. So P, D, Q is the 3 P's that we should be worried about when trying to do modeling. Okay. Now, as I said, series is so if you combine entire ARIMA, this is AR and MA, so it will become A1 YT1, A2 YT minus 2, blah blah blah. Then BU means you are combining AR and emitter. Only AR is the left piece, and only MA is the right. If you combine this, I have taken care of, I must have done differencing to make sure that my data is stationary, and then I am doing PQPs. So this is ARIMA equation, right? After differencing. Any thought, any comment, anything that we are confused about? No, right? Okay, great, thanks. So we understand this ARIMA piece, and we know what AR means, what MA means, what I means. I needs to make life easier for me, that is to make things stationary for me. Auto regression, MA is moving average, AR talks about Y, MA talks about error, right? This is ARMA or ARIMA ARIMA. We will just take, I will say, 10 minutes break, and we will connect again, and we will run models using ARIMA for the same data set, for which we ran SES, DES, and TES, and we will see how that ARIMA is performing. Okay. So Supriya will take 10 minutes break. 12:10 we all are here.
Sure, Rajeev.
Thank you. Shall we start?
Yes, Rajiv, we are good.
Okay. Okay. Thank you. Okay. So I guess we all understand what is ARIMA. Whenever we think of ARIMA, I mean, it is not very different. It is just a equation with different components like AR, MA. And as I said, stationary is one of the important piece because it makes life easier in forecasting, right? So if you look at the graph below, the left is stationary, right is non-stationary, and we all can understand because left part is more or less moving on the same level. They go back, they go up, come back, and so on. But the right part is coming down significantly, then again moves up, then again. So it's with time the property is changing drastically. So stationarity is one of the requirement for the ARIMA model. How do we actually check whether the series is stationary or not? So there is a test called augmented Dickey-Fuller test in statistics. We will do this test just now in R also, R studio. We'll execute this and p-value will tell me whether this is stationary or non-stationary. Okay, and if data is not stationary, we have to make this data stationary, and we have to then run on that piece our next set of ARIMA methods, right? So ADF test, well-known test for the stationarity check, and stationarity is one of the necessary conditions to execute ARIMA model. Okay. So we'll go to our studio again. Now our ARIMA world begins. Okay. So just run this command. Our train data is called train_TS. ADF.test in the bracket, you will have train TS. Everybody, let us run. No, let us not make that statement that stationary is trained. We should not. Stationarity is when mean and variance, the property of the data changes with respect to time. And it can go down, it can go up. Sometimes it can go down, sometimes it can go up. So that piece should not be happening in stationary world. And through the numbers I showed you in Excel, right? I mean, how the stationarity means. It should not that the sequence that I gave 1, 2, 4, 7, 11, 16. Maybe then again after 16, maybe 15, 14, 13. So it is like when you have a constant chunk of time, say you want to understand three months separately, it should not happen that these 3 months or 6 months are showing very different property in terms of mean and variance. Yes, should remain. I will not use the word same, I will use the word similar, because in statistics, same is, that's why, I mean, the difference between mathematics is same, statistics will use the word similar. Okay. So once you do this ADF test, for example, in this data that we do ADF test, see what happens. Don't read lag order and all those things. We will, for the sake of simplicity, we will only read the p-value. P-value is here. Okay. P-value, if p-value is very less, we reject the null hypothesis. We reject the null hypothesis. In case of Dickey-Fuller test, the null hypothesis is data is non-stationary. In case of Dickey-Fuller test, null hypothesis is data is non-stationary, and p-value is very less, 0.01. Anything less than 0.05, if the p-value is less than 0.05 in statistics, most of the cases we say that we will reject our null hypothesis. In this case, our null hypothesis is data or the series is non-stationary. So here my p-value is less. It means I will reject that statement that data is non-stationary. It means what will I say? The data is stationary. So it means in this case, I will not assume the data to be non-stationary. Right? So the Dickey-Fuller test says that it is stationary. Okay. We will come to this ACF PACF later. We'll first try to fit some model so that we are well aligned with the time that is there at our hand. Okay. And then I'll come to ACF PACF later on. Or let me tell you in short. There is a command called ACF in RStudio. There is a concept called ACF. It is called autocorrelation function. Till what value of P it is considered low? 0.05, 5% is considered to be low. Again, it depends on the domain and the customer you are working with. For many pharma medical industry, the P value low can be like 0.01. Anything more than 0.01, maybe they will say that it is high. But in general, in statistics, people say that 0.05 is the low value that we should go ahead with. Anything below 0.05, we will say that p value is low. Okay. Now there is something called ACF. ACF is autocorrelation function. It is like who is related to what. So autocorrelation, I mean, how lags are related to each other. It means if we know how to calculate correlation, autocorrelation function means I will calculate correlation between y and lag of y, right? For example, the series that I was just showing. So I have this say y, then my lag of y will be what? This, right? Correct. So this is my lag of y. Similarly, I can create lag 2 of y, right? This will become right. Now, if I calculate the correlation between y and lag y, what is the correlation? If I calculate correlation between y and lag 2y, I'm sorry, I wrote 3, it is 2. So it means I am calculating auto correlation. It means y's correlation with lag of y, lag 2y, lag 3y, lag 4y. It means it is giving me a hint that how many lags should I consider? Who is mainly driving this y? Is it yesterday? Is it day before yesterday? Is it even a day prior? And so on. That is called ACF. Similarly, there is a concept called PACF, partial autocorrelation function. So partial autocorrelation function is like, I know yesterday is related to today. It means yesterday will be related to day for yesterday also. If yt is related to yt minus 1, it means yt minus 1 is related to yt minus 2. It means you cannot say that everybody is related. Actually, you are reading it in that sentence, that intention that things are looking like to be related. So partial correlation means, is yt related with yt minus 1? Is yt related to yt minus 2 and not yt minus 1? It means I have to remove the effect of yt minus 1. It is like father and mother may have correlation just because they have the same son, right? But if you remove the effect of son, now you try to see the correlation between these two. Are they related? Are they correlated? And so on, right? So partial correlation is when you remove the already existing correlation, right? So to understand strongly whether y is related to or today is related to day before yesterday, we need to understand that I will remove the effect of correlation between today and yesterday. And once that relationship is gone, now I will see how today and day before yesterday is related. If that is there, it means day before yesterday is explaining my today, not via yesterday, but directly. If you are explaining via, then it is not partial correlation. So partial correlation means you remove that via, right? So we say that if we have only AR model, if we have to make only AR model, not ARIMA model, say only AR, then the PACF helps you, give you what should be your ARP. So AR needs PDQ, right? So ARIMA needs PDQ. So AR means P. So what should be the value of P? Gets generated by PACF. I will not say it gets generated, you can have an idea. Similarly, if you have only MAPs, you can get the information about MA using ACF. We'll come back to it again if we are able to run every subsequent thing before, and we can discuss this ACF, PACF again. The only thing is ACF is for MA, PACF is for AR. But the model that we will run is combination of everything. It is ARIMA, everything AR, MA, integration, everything, right? So ARIMA fit, if we have to do, assume that I don't use seasonality. ARIMA, you have the flexibility of not using seasonality. So if I use this command, everyone try this command. That ARIMA fit is the model name I am giving, and auto ARIMA is already there in RStudio. Train TS is my training data, and I will say switch off the seasonality. Switch off the seasonality. Let us switch off the seasonal. What happens? Right? I hope no. No, it is the ADF which shows. ADF test is something that tells you the p-value is telling us that it is non-stationary, right? ADF is always trying to look at. Again, I'm trying to answer a question on Q&A. ADF is always trying to see whether YT is a function of YT minus 1 and all those things. The difference of 2, YT minus 1, YT minus 2, and so on. So linearly, are they related? In terms of, is the difference explaining? It means there is a pattern sitting in, right, of increasing, decreasing, as we saw. So ADF is p-value less means it is stationary. ADF p-value more means it is non-stationary. Okay. Everybody ran this ARIMA fit. KPSS is also used to check stationarity. So why does KPSS reject stationarity? See, we always try to use 2-3 ways. ADF is the most standard way people practice. But as I've been saying from the yesterday only, statistics is not pure mathematics, and there is always ambiguity piece. For example, somebody can say 0.05 is less. Somebody can say no, 0.06 is less. And somebody can say 0.01 is less. So it depends on, the only thing is when KPSS, ADF, everybody is telling me same story, we have more confidence. Everybody is rejecting is as say stationary. Then we say that, okay, I have more confidence. But there are cases when you will see that one test will support you, one test will say we are against it. Then you get confused, right? And again, we always then try to see where the accuracy matters. Is it better? Is it trying to explain what we were trying to do and all those things, right? Some sanity check is like, I mean, see that stationarity is maintained through ADF tests and move ahead, right? Now, if you run this ARIMA fit, seasonality false, what happens? Everybody is getting this? This is called 313 model. It has run the best model, and it has AR1, AR2, AR3, MA1, MA2, MA3, and everyone's coefficient is there. AR means AR1, AR2, AR3 means 3 lakhs it is going ahead with, right? So A1 YT minus 1, A2 YT minus 2, A3 YT minus 3 plus beta 1 error minus 1, beta 2 error minus 2, T minus 2, error 3. So all these coefficients are coming in front of us, right? And it gives you AIC value, BIC value, and so on. And we know in statistics, whenever AIC is less, we show that we have more confidence in our model, right? So if you assume that you believe on this model and you try to forecast for next 91 days the way we were doing for SES, only thing is the command or syntax is not same as what we had for SES, DS, and TES. So make sure that you use the correct syntax. You will see that ARIMA future is the name I am giving. The forecast, there are 3 colons, double dot, double dot, double dot. Can you see? Then you will write forecast dot ARIMA. ARIMA fit is the model name and how many data points you want to forecast for. That is horizon equal to 91. So it is the horizon. See if we are able to run this. Don't worry about plot. We'll calculate the error and see what it is giving us. Everyone, anyone who has run this ARIMA future, are we able to run line number 146 and generate? Okay, great. Many people have done this. Now, if I have this forecast, go and run these two. We will calculate WAPE in terms of train and we will calculate WAPE in terms of test. Let's see what happens. We will calculate WAPE of train and we will calculate WAPE of. You can copy the previous SES DS because it's nothing changes. Only thing changes is the input that we are giving. Or you can, whatever is suitable to us. So I am giving name ARIMA WAPE train. WAPE is the function and 2 argument that it needs is train TS and ARIMA future $fitted. And when you are in test world, you will use WAPE test TS, ARIMA future $mean. So if you run these two and then print train and test, look at the error. Error is ARIMA is also giving. Everybody, are we able to run and get the WAPE of ARIMA with respect to train and with respect to test? No? Anyone who can confirm? Everyone is getting MAPE of 35% and 52%. Okay, yes, great. Now, this error is also not a small error, 35%, 52%, right? TES was doing much better, right? But you know what we did? We have removed seasonality when we were running this ARIMA. So what we will do is, now we will not run the same piece. Only thing is, don't put seasonal equal to false. Same command, everything same. Don't put seasonal equal to false. Okay. Say I'm running the same thing, and I will again have no plotting as of currently. I was just giving name WS means with seasonality. And let me know what is the percentage error we get. Great, 14.3 and 18.4. Varun has got it. Yes. So 14.3 and 18.4. This is much better than what we had earlier. And this is even better than, I think, the TES model. Right? So our train error is small, our test error is small, and they are not very much apart. Right? It should not happen that your train error is very less and test error is very high. Then it is like you have, or we have, mugged up for the exam and we didn't do well in the exam because of the mugging up, overfitted, right? So this is what seasonality brings in. So seasonality will always, if data has seasonality, it will try to address, and that is why I intentionally wanted to run with and without seasonality, right? And the moment you have seasonality will have its own component, its own parameters, right? So are we good till now? The ARIMA model with and without seasonality. If you want to look at parameters that gets generated when you run auto ARIMA with seasonality on. By mistake, I ran it again. Okay, no problem. So you can see it is a 401012 model. First bracket is about normal ARIMA, PDQ, small PDQ that we talked. The second is about, actually it is calling about seasonality. It says that I am talking about 012. It's the capital in literature. It is called capital P, capital D, capital Q. And bracket, don't worry. Bracket is like, how many, the frequency we had taken 7, right? So that is what the seasonality or frequency that we had taken, it is 7. So it means AR term is 1, 2, 3, 4. MA term is just 1, but seasonality MA is 1, seasonality MA is 2. There is no seasonality auto-regression. There is no seasonality auto-regression, right? And these are the coefficient that gets used to forecast for the ARIMA with seasonality, right? I am assuming that we understand this ARIMA with and without seasonality, how to run it, and how to generate the train and test error, and then to understand how the output looks like. Okay, now I will go back and try to see if I run without seasonality, but what I will do is I will use in ARIMA, I will use one of the independent variable, which is, you will see in your data set. When I was showing you the data set, if you remember it, there is a variable called is holiday. It means Monday, 1st January 2018 is a holiday? Yes, that's why 1. If not holiday, it is 0. So it means again 15 January was a holiday from the country this data is from. Okay, this is again holiday, right? Now I have a variable called holiday. Is holiday is a variable. Is holiday. I want to see, does this variable have any impact? Does it help in explaining my ARIMA little better, or it is not? Okay, so we will try to use this, and we'll again try to use with and without seasonality. So let us run this. What I am doing is, again, same training data, same test data. We will, instead of ARIMA fit, we will say Remax fit. X means the extra variable X we are bringing in, right? So try this. Auto.arima, train TS will remain same. You can write seasonal equal to false. X reg, it means X regression, extra regression, or the independent information that we are bringing in, that is there sitting in this data called data. Now I should take only those much which is there in the training, right? So I will take 1 to 1400 rows, and which variable I will pick up is holiday. Try this and see if it is working. As of now, I have just taken seasonal equal to false. Okay, and once I have run that, I can again forecast the future. No, don't. I mean, it okay. Is it? It is giving us error? I don't think it should give us error, because it should not be numeric for us. This holiday was categorical. 0 means no holiday, 1 means holiday. So it is not number for us. Try, it means it is. See, I mean, in calculation, it needs mathematical number, but it should not have, because we have given 0 and 1. Try converting that into numeric. I don't think it should have created a problem, but try again converting this into numeric. Say in the beginning of the code, wherever we are doing this. Okay, you can add is holiday as dot numeric, you can write, so that you don't get error. Ideally you should not. I don't know why, because I didn't get that error. But yeah, and that's why every time I always try to be very careful, so that I can convert that into now NS will be introduced. In, I don't think I was getting, for example, if I run this and if I print this, see, I got AR1, AR2, AR3, MA1, MA2, MA3, XREC. -2173 is the coefficient that I am waiting for X regression. Everybody is getting the same problem. I hope seasonality, seasonal is F. Your code doesn't seem to be wrong. Auto.arima trend TS, seasonal is F, xreg equals data 1:1400, is holiday. Yes, after that you closed it. Why it is giving error? It shouldn't be as. I hope you have that variable in your data set. Just check that that variable is there in that data set. I mean, you should not read the data set, just print. Anyone successful with this Remax? Anyone? Okay. People are, some of us are. Okay. Once you do this, again, we can do the Remax future forecast. So we can forecast. Again, in forecast, you have to give xreg carefully. You should not give one record more or one record less because it will not understand. So my data set ends at 1491. So 1401 to 1491. And based on this gets forecasted. Great, Amrita also ran. Okay, now if we have done that, I can again go and calculate my Remax WEP in train and the Remax WEP in test, right? And I can print that. Now you will see 33% and 49%. If you compare this with the Arima, which was Arima without seasonality, it is doing relatively better than Arima without seasonality. This X is again not very great, but yes, definitely better than when we were using Arima without seasonality. For example, if I reprint this, so you can look at my console. 33 and 49 is for with X regression, and 35 and 52 is for without X regression. It means X regression reduced your error. I will not say significantly, but yeah, minimally it has reduced. Right? If I run the same Remax with seasonality on, so wherever I had written seasonality equal to F, you can remove that seasonal equal to F and then run. You will see a much better output or error. Let's try. This is a Remax with seasonality. Everything remains same. Only thing changes is you have to remove the seasonal equal to F, because by default our studio takes seasonality equal to on. Correct. So the Priya says with seasonality, Remax results train is 11.8% and test is 15%. Right? So we are doing much better. So I'll also run and see what is happening. Right? So 11.8% and 15%. Right? Earlier we were sitting at 14% and 18% when we had not used X regression. So this independent variable, this holiday, actually helped us improve our accuracy to some extent. Right? And you will see that I have always taken the third type of WEP, that is harmonic mean. It is just, I try to make sure that when you use train and test, it should not happen that one is very high and one is very less, so that even if one is high and less, the harmonic mean will become significantly higher only, so that you can choose based on different say models, which is giving you better accuracy. For example, here if I print, oh, I have not even run this. So if I print in last model, my harmonic mean between train and test WAP is 13.24%. Right? And I can do the same activity here. So without X regression, oh no, without seasonality, X regression is giving me 40%. Right? This is giving me 16% without X regression, but with seasonality, it is giving me 16%. So you can compare 13 versus 16. So 13 is with seasonality, with 16 is with seasonality without X regression. So this is relatively better, right? And you can test everything like this, right? Again, this is for, I mean, you may choose to ignore, you can just concentrate on train and test separately and do it. TES also, I'll just see what is my, yeah, it is 15%. Right? Even DES, I can check 57%, too high. SES, the HM, the harmonic mean is 50%, again too high. Right? So we have run many models: SES, DES, TES, ARIMA without seasonality, ARIMA with seasonality, Remax without seasonality, ARIMA with seasonality, and so on. Now, assume that we have done this and we want to look at the output of output in a table so that I can compare which model is giving me what. Okay. So this is what, I mean, you can just create a data frame. SES, DS, TS, ARIMA, ARIMA, WS, I don't know. WS means with seasonality. Remax, this piece. Train error is SES wave train, DS wave train, this. Again, I am just making a table. Okay. If I run this table, and then I run this cable command, KABLE. This gives me a table below, table in my console, and you can compare all the models. SES, DES, TS, ARIMA, WS, Remax, WS. And you can see the trend, test, and harmonic mean of the error. And this table tells me that I should concentrate on the last model, where train is 11.8, test is 15.02, and the harmonic mean of these two is 13.24. Right? If I have to choose the second best model, I will choose the TES model, maybe 12, 18, and it is giving me 15. Right? But we have to be very careful whenever we are choosing between TES and ARIMA WS. TES and ARIMA WS. Although the harmonic mean of TES is smaller than the ARIMA WS. Harmonic mean of TES, if you look at the screen, it is 15, right? And the harmonic mean of ARIMA WS is 16. So you will think that I should choose this one. But sometimes you have to take care that, okay, this 15 number may be telling you that I'm less. But when you go to this train and test separately, you will see that the difference between train and test here is bigger than the difference between train and test here. Right? So whenever somebody is performing relatively similar in training, in classroom and exam room, it means whatever learning that person has, it is like robust learning. There is no cheating, there is no mugging up, all those things are not happening. But when your class exam goes very well and your a real exam, test exam goes not that well, then there is a question. Maybe we should not believe on this candidate, right? So we'll believe on this candidate more ARIMA WS than the TES in terms of accuracy. That's why we should look at both train error and test error, right? Again, I just made this table. You can always print separately and decide what is going to be your test model and how do we run. Make sense? Question on this, and we know how to forecast, and then you can always export your output in the folder. Instead of read.csv, you will write write.csv. Any forecast that you may have, and you can just like read.csv, you can forecast if you want to forecast for using some variable, using some model, right? For example, I mean, if you want to use, I don't want to go with auto ARIMA. I want to use my particular variable, particular model with parameter that I want to use ARIMA with order as 401 and seasonality as 012. Independent, yes. Question is yes. You can use n number of independent variable in Remax. Dev say no. Okay. You can use n number of variables in Remax. Okay. So for example, somebody will say that I will run this model. I will forecast for next 84 days, right? And you will say that I will use that, and this is your date, for example, for those 84 days, and you create a data frame, and then you want to write it in your you as a CSV in your folder. So this is the name which you have just created, the data frame, and this is the path where you want to store, and at the end you can give whatever name you want to give, right? For example, date is 24/03/2022, and I can run this. It has come to my folder here, right? It has this one, see, 24. So this is my forecast that will be there in my folder. No, it is still opening up. Yeah. So this is my forecast that the system has given for all the various dates from 31st January to, because I had data till 30th January, I will forecast for 31st January, 1st February, and so on for 2022, and then I will see. Maybe the end date we have selected is 24th of April. So 84 days, maybe 12 weeks data we just forecasted, right? So you can forecast with whatever model you want. Only piece is that whenever you are using Remax, make sure that if you are forecasting for future, you have the value of the independent variable available for the future. You cannot say that I don't have holiday information for April, May, but I want to forecast for April, May using Remax. Then we cannot do, right? So ARIMA you can do, but Remax you cannot. Remax needs independent variable X. That X needs to be made available prior to running the Remax model if you are trying to do model running or future forecasting. I will just take a pause, and I will assume that okay, our basic structure is done and understood. Are we good? In terms of running SES, DES, TES, ARIMA with seasonality, ARIMA without seasonality, Remax with seasonality, and Remax without seasonality. So 7 P's we should have, and we should compare our output. Again, everywhere I didn't make the plot, but that plot remains same. Only the output number changes. So you can see which plot looks better. Error-wise, we can always compare the numbers and see who is better. Plot-wise also, if you want to make some interpretation, we can, right? Okay, great. So Manisha says yes. So we are good. So I mean, I know. I mean, the data set actually you worked is a real data set, and the model. I mean, real time we did modeling, 7 different modelings in R. Yesterday we tried to do 2 in uh, Excel, and through optimization and so on. So I think, and we understand what is the ARIMA equation. What do we mean by AR? What do we mean by I? Why do we mean by MA? Stationary, right? Adf Test, all those things. So overall, again, nobody can become expert in 2 days for sure. We need to practice. We need to understand. We need to go back. And the problem with data science pieces, I mean, there is no perfect. I mean, nobody can get 100 out of 100 in data science, in machine learning, just because nobody can get to the 100% accuracy. Nobody knows unless two things, God or liar, right? That somebody will say that I have forecasted correctly. No. So whoever is better, there can be different methods. For example, in this case, we tried to build ARIMA models on daily data, right? Somebody can suddenly get up and tell me that what I will do is, I will not run ARIMA on daily. I will bucket my data in 7 different P's: Monday 1, Tuesday 2nd, Wednesday 3rd, Thursday 4th, Friday 5th, Saturday 6th, and Sunday 7th. And I will do 7 different time series models, and I will forecast for every weekday and not for continuous day. Maybe Monday is affecting Monday, and I will use that, and maybe that person comes up with a better accuracy than what we have, right? So, it is not, there is not one path. It is that's why it is not process. Please let us not understand this is a process. This is a puzzle, and we all are trying to solve this puzzle. 100% accuracy is very difficult to get unless things are deterministic, like number of days in January. I know this is deterministic, but number of people in India in 2031, very difficult to predict. Nobody can predict with 100% accuracy. Something will go wrong, right? So make sure that we try to understand many pieces. Many people will do what? They will do weekly model, and they will break it into different days using some logic. And then they will see that, okay, my model is relatively better, right? So many iterations, many versions, somebody can create and come up with. That's why it takes time whenever you are trying to build model, because there is a button kept somewhere that you will press in. I mean, AutoML, I know we all are trying, but still, we have to understand that which one will work in which case. Okay, so here I will summarize the I will say that we have almost closed the forecasting piece. Okay, so forecasting is what we are, why it is used. I mean, what are the different components? I mean, what are the many techniques? All these 7 techniques. Did I cover all the techniques? No, there are hundreds of techniques of forecasting. I covered 7 of them, which is 7 of them are not less important. They are heavily important forecasting techniques, but people may use many different. For example, deep learning based people can use LSTM. Somebody will say that I will use some random forest based models. Somebody will say that I will use unobserved component modeling. Somebody will say I will use vector error correction models, right? Vector auto-regressive models, and there can be a number of models that can be. Somebody will say I will run profit model. Somebody will say I will use Fourier series transformations. There can be a number of things done, and somebody you don't know which will work better, right? So these 7 are important. Always try and see to get answers for your forecasting problem using these 7. If these don't work, then only go for, I think, the most advanced or the some newer techniques, right? I think we will take 10 minutes break, and we will again meet, and I'll just show you something around what do we do with these numbers now. And I know we cannot do it in R and Python, all those things, those steps, but still I will try to make sure that you understand what we do. Maybe I will not be able to say teach you how to do, in say Python or in R Studio, because it needs different expertise like writing equations from our side, making constraints and all those. But still, I just wanted to give you a flavor what people do with this output, and then only the loop will be closed. So it's 1. Can we meet at 1:10? Supriya, it's fine, right?
Yes, yes, absolutely.
Okay. Okay. Thank you. Shall we begin?
Yes, Rajiv, we are good.
Okay, thank you. So, what do we do with this forecasting numbers? Okay, we have forecasted, for example, in our use case, again, I'll reiterate what the use case was. It was about generating the alert volumes while making a payment. Okay, an alert gets generated whenever there is an unusual payment. And particularly it is from the sanctions category or sanctions type of say alerts, right? So if there is sanctions there, you cannot send money to that location, or there is a limit and all those things. So alerts gets generated. This alert, how will we use it? Now I'll just walk you through. So this is, I call this sheet as planning. I must have sent to all of you. So this is for the forecasting period that we have generated for those 84 days. Day is aligned, and assume that some model has given me this many number of calls for various days, right? This is the information that comes from me, to me from the business, or we have analyzed the data and tried to understand what should be the average handling time of these calls or these volumes. Don't think as calls. This is actually number of alerts. Okay. Now AHT in minutes. So all this, assume that we all decided that on an average this will take 3 minutes of handling time. So it means every ticket or every alert will take 3 minutes time, and on 31st of January I need to address 6,828 alerts, right? It means if I need 3 minutes for each of them, so in terms of hours I need 341.38 hours. Again, this is first week, so it is just like week information. So I'm in the first week of, say, January. It will finish on Sunday, then again Monday will begin, and so on. Now this information is given to me that okay, in general employee or resource comes to office for 8-hour work, but you know the effective work, that efficiency that we can call it, is taken as 6.5 hours, because we'll understand that 1.5 hours every day will go for, say, some breaks, some meetings, right, some trainings and all those things. So 1.5 hours gets deducted, so 6.5 hours availability will be for each resource each day. Now if I do this, it means the resource on Monday 31st of January I will need is how many? 43, right? It is E2 by, again 8, it's wrong, not 43, I should write 6.5, 53, right? So these many resources I need, because I need 341.38 hours of working, and every resource will work for 6.5 hours. So I need 53 resource on day 1. I need to have 56 resource on day 2 by the same calculation. Then 51, then 52, and all those things. Saturday I need just 7 resource, and they will be able to solve the problem, resolve the cases. Now one more information I am given is the cost that is incurred per hour. On weekdays it is $14 per hour, okay, and the cost incurred on Saturday Sunday is $20 per hour, okay. It means cost is different on weekends than on weekdays. Again, we can always tweak the cost and see how the things are changing. You can always simulate other things, right? Now what my plan is that, okay, assume that This again, this is a hypothetical situation I have created, as if somebody is starting the process. So forecasting is done. Now this is the first day of the process. The system will start on 31st of January 2022. I have no resources till now. Now I need to have resources onboarded, and they should be able to take care of these many calls. So what we are saying is that, okay, Monday, how many people should come? On 31st, say I will ask 30 people to join. On Tuesday, I may ask, say, 10 people to join. Wednesday, I may ask something else. Thursday, I may ask something else, and so on until Sunday. Now, what happens is, after every 5 days, you have to take 2 days break. You can always tweak it. You can make the break as 1 day. In my current scenario, let us say we will take say 2 days break after every 5 days. So it means the guy who had started working on Monday will be not available on Saturday and Sunday. The person who had started on Wednesday will not be available on Monday and Tuesday, coming Monday and Tuesday. So assume that number of resources that I will hire, and they will be onboarded on day 1 is 51, right? Maybe 10, maybe 12, maybe 1, 6. So 7 days, 1, 2, 3, 4, 5, 6. So 6, 9. So it means I started with 51 on day 1. Then I will have 10 on day 2, 12 on day 3, and so on. So cost will be like, on this day, I will have this many costs. On this day, new cost will come. This day, new cost will come. This day, new cost will come, and so on, right? And how this cost is getting calculated? This is getting calculated using how many resources are there, and what is the cost per hour, and how many how many hours you work, right? Now, if you use this terminology, then you will have some cost associated to it. And then I will see that, okay, what is the resources available on each day? Day 1, I will have 51, but next day I will have 61 because 10 has extra been onboarded. Then I will have 73 because 12 are now extra. Then I will have 74 because 1 comes again. Then I will have 80. Then I will have 35. Then I will have, why 35? Because 6 will come, but this 51 will take off. Then 34, right? This 9 will come, but this 10 will take off. And then I can see that, okay, every day, how many people will be available to, right? Every day, how many people are available to. And I want to optimize my weekly cost. So what is going to be my weekly cost, right? Now, weekly cost is how much? First will be, this is 1 day cost, right? This person is available for 5 days. He is available for 5 days. He is available for 5 days, 5 days, 5 days, 5 days, 5 days. So if I take sum, or if I take the sum and multiply with 5, doesn't matter. So I will try to optimize this number by changing this number, this yellow one. I will try to optimize this number by changing this number. Again, I am giving you a flavor. I mean, if you are interested in solver and all those things, you can try this on Excel. Otherwise, in our deliverables, we always use to and these are very easy constraint that I have given. And there is no constraint. It is like these many people, this is the hour, and how do we convert it into? But your constraint can be very complicated, very difficult in terms of that there are 10 people who come, there are 10 people, maximum 10 people who can come in this shift. There are 13 people who can take calls of X state and as well as Y state. There are 42 people who can take calls of only Z state. And there can be n number of constraints given. For that, then we need the R coding, Python coding, and then we solve the problem there, optimization it is called, and then the real scenario will come that okay, minimum cost is obtained at this level so that your cost is minimum, and at the same time you are able to meet maximum of these, or you are able to address maximum of these alert reviews. Okay, so this is very easy. For example, I have just said that, I mean, on day one or any day you can maximum onboard, say I am just giving 60, and minimum every day you have to 5, for next 5 days you have to onboard 5 people. So if this is the case, then this is where I am, and again this is like into 5 it will become the actually cost. So you can take this, minimization doesn't change if you multiply or you don't multiply. Then I'll go to solver, and I have many things written here. I will minimize what? My cost. So that's why P2 is sitting in my cost. I will do that P2. I will minimize. So I will have this button on, not maximize, not value, but minimize. By changing what? I will change this column L. How many should I start calling them from Monday? How many from Tuesday? How many from Wednesday? How many from Thursday, Friday, Saturday, Sunday, right? Now these are the constraints that I have written. All these L1 to L8, all these should be less than equal to K2. What is this K2? K2 is maximum that can be onboarded on a day, right? Because there are some process that needs to be done, the onboarding process. Maybe our system cannot handle more than 60, right? So 60. Similarly, all these L1 to L8 has to be integer. You cannot call 51.5 resource. Resource will always come in integer, 2 resource, 3 resource, 100 resource. You cannot have 100.5 resource. That's why these are integer. All these L1, L2 should be greater than J. J means what? Minimum every day for those 7 days, you have to onboard 5 people for the onboarding purpose, because otherwise my team who is supposed to take care of the onboarding will be sitting idle, right? So 5. Now these all are different type of O is resources available, right? Now this O should be greater than H10. H10 is what? What is my H? Resources required, because I need 53, which will be able to take care of the calls that I have just predicted, right? So I need 53 people who will work for 6.5 hours, everyone, and they will be able to address the number of alerts that has got generated. It means this day O is the number of resource available to me. This should be greater than this H or equal to this, right? Similarly, next should be greater than equal to that. So all these things should be mentioned here. That's why all this constraint will come, right? And here I will say that I'll go ahead. I will say that, I'm sorry, there was a digression. So we'll do all these things and we can run, say, very simplex method, the linear programming method. And if you click on this solve, let's see what happens. Solver found a solution and this is the answer. It means it says on day 1 just ask 53, otherwise every day you just manage with the minimum number of resources that you have to do, and these will be able to take care of all the alerts that gets generated, and this will be your weekly cost that is going to be with you, because this is weekly, these are the weekly work we will be doing, right? So this is how, again, this is a very simple framework that I just created to give you a flavor that how things do not stop at forecasting. You use that forecasting to make some strategy. In this case, the strategy is, do you have enough resourcing at place to take care of all the alerts, right? And these alerts were generated by our forecasting engine. So forecasting is very important. If the forecasting is wrong, My resourcing may become, if the forecast is too high, it means I will have to hire more resource, I will have more cost incurred. If the forecasting is under forecasting, then I will have less resources aligned, and I may miss to resolve the alerts that get raised actually, right? So we have to be very careful that our forecasting should be robust, it should be good enough, and then your optimization should take care of, or your planning should take care of, your recommendation should take care of that input and the various constraints that you may have, that your resource may not work for more than 6.5 hours, they are not productive for more than 6.5 hours in a day. The resource will come for 5 days, will not come for next 2 days, they will be off, right? Minimum number of resources that you need to be onboarded is this much, maximum is this much. Very simple scenario again. There are constraints like this in hundreds, right? And we have to take care of all those constraints, and Excel sometimes becomes difficult to handle in case of when you have too many constraints and you have very difficult problem, and particularly when the problem becomes integer in nature, whenever you don't have say decimal allowed, you cannot have 2.5 resources, right? You have 2 resources, 3 resources when you are hiring. So then life becomes more difficult, things will takes more time as the constraint increases, just because Newtonian way of doing optimization or maximization, minimization that we have learned in school, that differentiate equal to 0 and all those things will not work, because the fundamental assumption under Newtonian optimization is everything is continuous and differentiable. But if you have only integer, then they are not continuous. 1 and 2 are not connected. It's the real numbers which are connected: 1.01, 1.02, 1.03, and then 222. But 1 and 2, there is a gap. So the moment we have break, continuity is lost. It means differentiability is lost. Differentiability lost. Newtonian physics or mathematics will not help us to arrive at the optimum or maximum or minimum answer. So for that, we have to use evolutionary algorithm, genetic algorithm, right? Integer programming, mixed integer, linear programming, dynamic programming, all those things. It's a vast field, and people use it to make planning. But that planning, I have seen that most of the time consumes forecasting or machine learning output as an input, right? So somebody will do some forecasting, somebody will do some machine learning based algorithm, and then that output will be consumed by an optimizer or planner or the recommender, and then recommendation gets generated, right? And it happens everywhere. For example, you can make a very nice model trying to describe why forecast the sales, that sales is impacted by different types of ads, but then there is a budget given to ads. Now, how do you distribute that budget to different ads? For example, how much budget should be given to Facebook ads? How much budget for my product should be given to TV ads? How much should be given to print media and all those things? It means I know through the machine learning that which variable is important or which ad is important and how much it is important in terms of effectiveness, efficiency, and all those things. But I do not yet know how do I distribute my budget, because you cannot say that my TV seems to be more effective, I will put everything in TV. No, you cannot do that, because there is a saturation, all those things starts coming into a picture. Just because TV shows Maggie ads 100 times, that does not mean that Raji will start having Maggie, say 10 Maggies instead of 1 Maggie, right? So there is a saturation. So all those things will then need the optimization, and that constraint that I said, saturation, all those things will be used as a constraint to distribute your budget into different vehicles of those media, for example. Similarly, in forecasting, as I said, you need to use all the constraint. You may have budget at hand and you want to take care of all the alerts. Now, how do I do that? So you need optimization, you need recommendation, you need planning, capacity planning, and then you need to schedule all these things. So that's why I'm again saying that forecasting is alone is not the end. It is just a means. We need to use that forecasting to arrive at a business decision, that what should I do with this forecasting, and unless forecasting is correct, my planning will not be correct, right? So make sure that our forecasting is correct, and then some planning is done on top of the forecasting, right? I'll take a pause. Any doubt, question, if we have, we will try to address, because from my side, I think this is what I wanted to cover with respect to optimization, because writing codes constraint in Python are not easy. I mean, you cannot just call a function and run, just like Arima fit we called, right? Arima, auto Arima, nothing like that. We have to understand the constraint and we have to write it in a mathematical structure and then use that in correct format, whether you want to use open solver or you want to use some licensed solver. Okay. I try to. Okay. Thanks, Arma.
Participants, any questions? Please feel free to queue in your questions on the chat window or in the Q&A window, and Rajeev can take it up. We still have some time, so please leverage the opportunity.
Thanks, Anand.
So Rajeev will give it a minute.
Sure.
No questions, we'll close. So we'll
okay,
just
no
give
problem.
time to the participants.
Thanks, Devsena. Thanks, Sandhya. Thanks, Varun.
Yeah, I can see a question if the recordings will be emailed. Yes, we will make the recordings available on our YouTube handle and we'll share the link also once published with all of you.
Okay.
Please
Thanks,
feel free to
Manisha.
subscribe to our YouTube handle. I've already shared the link with all of you. You can access the replays of all our previous events and workshops here. So Rajeev, I do not see any questions here. I believe there are, the participants are very clear and.
Okay, great. I just thought that maybe last 10 minutes, 15 minutes we should keep for discussion.
Correct. It would have been nice, yeah, to use this opportunity. So we'll give you another 2 minutes, participants. Please, I would request you all to make use of this opportunity. Okay, there's one question come in the chat window, Rajeev. Can you recommend book for multivariate time series?
Okay, book for multivariate time series. See, there is I will say that why only time series? I will suggest a book, I think, which will help us understand most of the things around not only forecasting time series, but even broad machine learning. There is a book called Elements of Statistical Learning. Elements of Statistical Learning. Try to go through that. It has many things in it and it has many references, and anyone who has access to this will really love to read and understand statistics from it.
Thank you, Rajeev. Manisha, I hope that answers your question. Okay, she says yes, Rajeev.
Okay, thank you.
I do not see any questions, Rajeev. So we will conclude this workshop. And I would like to thank you for delivering an impactful and engaging workshop on forecasting and optimization over the last 2 days. I'm sure our participants have lots to take away from the hands-on exercises. Thanks to Santhan for diligently responding to the live Q&As. And finally, a big shout out to our attendees for your valued participation. Do share your feedback on the workshop. We have dropped the survey link on the chat window. We appreciate your inputs. So do let them come in. Follow our social media handles to keep yourself updated on the events and workshops. Signing off from today's workshop is Supriya Samuel from KTech Data Science and AI at NASSCOM. Enjoy the rest of your day. Bye-bye, everyone. Thank you, Rajeev.
Thank you everyone. Thank you very much.